In this video, we're going to continue our study of the normal distribution. And so I wanted to do this example from your notes on the M&M activity. And so I collected the weight of 100 bags of M&Ms. And the task is to go to StatCrunch. And so you're going to go to StatCrunch and open the data, label M&M bag weights, save in our group, ARC Stat 300, Triola, and the task is to then draw a dot plot of the data, describe the data, then find the mean and standard deviation, and all that fun stuff. So this is the name of our group. I recorded a video showing you how to access the group if you haven't done so already. And here we're just going to practice how to do some more graphs. So let's go to StatCrunch, which should already be open from the previous video. And so go to My StatCrunch and go to My Groups. And then here you'll see the group. So ARC Stat 300 Triola, make sure it's by me, and then find the data. So we're looking for M&M bag weights. And so we'll click on that and the data loads. And so here we are. So those are the 100 data values, and we want to graph a dot plot. So this exercise is here to kind of help us review StatCrunch all over again. So let's go to graph, and these are all the different graphs that we can do, right? So we're looking for dot plot. So click on that, select the column that we want to do, which is the variable 1, and then that's it, and click compute. And so here is our graph. So the question asks us to describe the shape. So we can extend it, but this kind of flattens it out. It makes it look more like a uniform distribution than anything else. So we can kind of play with it. If I crunch it up, now notice that it looks more like a normal distribution. So I'm going to leave it maybe around there. And then I'm going to right click and then copy image, and so we're going to go back to our notes and I'm going to paste it in here. Maybe. Okay, I had to right click and paste it as a picture in order for it to post in here. So here's a dot plot. Describe the shape of the data. So how would you describe the shape? As we were looking at it, we say that it looks approximately normal. So we're going to say approximately normal or bell shape, which means that we can use all the normal distribution information that we have learned. So find the mean and standard deviation of the data. Now there are 100 data values here, so we don't necessarily want to do it by hand. And so since we're already using StatCrunch, let's go ahead and go back to StatCrunch and find the mean and standard deviation that way. So do we remember how to do that? So we're going to go to the Stat menu and then Summary Stats and Columns. And we're going to select our column again, which is variable 1. And we want the mean and the standard deviation. So to remind ourselves, and it kind of tells you here as I hover over something, notice the yellow that shows up. It says to select more than one. Do the shift and click at the same time, or control and click at the same time. So I'm going to do control and click to do the standard deviation. So now I have mean and standard deviation. Click compute, and it gives us over here our mean and standard deviation. So I'm just going to copy those onto our notes. So we have our mean and standard deviation right here, and now we can use that to find z-scores for the next. So part 3 is find the z-score for a bag that weighs 51.2 ounces. Is this value unusual? And explain. So let me put that in red so we can see it a little better. Now find the z-score for a bag that weighs 51.2 ounces. Is this value unusual? So remember that in order to find the z-score, the formula for the z-score is the data value minus the mean divided by the standard deviation. And so in this case, a 51.2 ounce bag, that is our x. So it will be 51.2 minus the mean 50.38 divided by the standard deviation. So let's round that to 2 decimal places as well, so 1.37. And let's put that on our calculator and see what we get. When you put this on a calculator, if you're doing it all in one line, in one entry, make sure that you do parentheses and then do that, and then close the parentheses before you do the divides. And so let's put that in and see what we get. So when I did this, I got 0.5985, which we can round to 2 decimal places to 0.60. So is this unusual or not? And I would say it's not unusual. Remember, the rule of thumb is that if you are more than 2 standard deviations away, then the value is considered significantly unusual. So, but this is even less than 1 standard deviation from the mean. So we're not. So this is in the thick of the data. So it's not unusual. Again, if you're more than 2 standard deviations away from the mean, that's when it's considered unusual. And you can look at the notes from the previous chapters, inside chapter 5, where we did the significance. And I had the graph with the mean, and then 2 standard deviations over was unusual. Now for part 4, find a z-score for a bag that weighs 46 ounces. Is this value unusual? So we'll do the same thing, but now instead of x being the 51.2, x is 46. So that's our x. So our z-score is going to be 46x minus the mean 50.38 divided by the standard deviation 1.37. And when you put this on your calculator, we are going to have, notice that 46 is less than the mean. The mean is 50 and this is 46, so it's going to be negative, right? So negative 3.197. So is this considered unusual? Yes, it's more than 2 standard deviations away. In fact, it's more than 3 standard deviations away. So this is considered unusual. So this is more than 2 standard deviations away from the mean. Remember, the z-score tells you how far away from the mean you are. Now find the probability that if you purchase a bag of M&Ms, it will weigh 52.8 ounces. So what this really is asking me to find is find the probability that x is, what is it, that if you purchase a bag of M&Ms, it will weigh 52.8 ounces. So let's say, what about if it weighs more than 52.8 ounces? So let's go to StatCrunch and figure that out. So back to, we should already have the data loaded. Yep, there it is. So then what do we do again to find the normal? So we go to Stat, Calculators, and Normal. And so we're going to put in our data here. So what we found was that the mean was 50.38 and the standard deviation was 1.37, rounding to 3 decimal places. And it's hiding behind here. So it's helpful probably if I put them side by side so we can see the mean is 50.38, the standard deviation is 1.37, and we want the probability that x is going to be greater than 52.8. I know it says 52.8, but we want to see if it's going to be unusual, essentially, so greater than. And let's see that. So this is going to be the probability of getting something 52.8 or greater is going to be, what is that, 0.0386. So this is going to be our probability, so not very likely. So go back to our notes, and so this is, let me put it in here so that I don't forget it. So this is our probability. So the probability is 0.0386 3.87, rounding to 4 decimal places. So as a percentage, this will mean move the decimal place 2 places over, so 3.87%. So not very likely, and this is 52.8 ounces or more. So to get it to be exactly 52.8 ounces is actually less than 3% then. And so not very likely. Going back to the previous example with the 46, notice how unusual this was. So this will be something that, and this kind of stuff is used in the quality control, right? So if this was in the factory for M&Ms, this bag, the one that weighs 46 ounces, will get pulled out because it is unusual. Its weight is more than 2 standard deviations away from what the average is, and so this quality control will pull it out. And then to ensure that nobody gets a bag with only 46 ounces of M&Ms, that will not be very good. Someone will not be very happy purchasing that. Okay, so let's go on to our next example. So I did say for this to try on your own, but I will do number 1 together, and then I'll let you try the other one, the heights of men, on your own, truly on your own. Okay, so for this one, a national study found that college students with jobs worked an average of 22 hours per week. Okay, so keywords, average, 22 hours per week. What did I just find there? This must be the mean. The standard deviation is 9 hours. So that's our sigma. And then it says a college student with a job is selected at random. Find the probability that the student works for less than 8 hours. So that's another piece of information. Assume that the length of time college students work are normally distributed. So that's important because that means I get to use the normal probability distribution and are represented by the variable x. So then I know the mean is 22. The standard deviation is 9 hours. So I guess we should put our units here. And we want to find the probability that x is the student works for less than 8 hours. So less than 8. And so how do we do that? So we can do, you can either by hand, you can convert to z-scores and use the table in the book to find it. So doing that, I will have the z-score equals, what is it, x, so 8 minus the mean, minus 22, divided by 9. And so do that on a calculator, and what do we get? I got negative 1.5555, so let's say negative 1.56. So then you go to your z table on the calculator, not on the calculator, in your book, and we're going to look for negative 1.5 and then 6. So let's go to our z table, and I'm looking for negative 1.5, and then we're gonna go, that's negative 1.50, 1, 2, 3, 4, 5, 6, the last one that I have highlighted there. And again, this is giving us the area to the left, so less than z, which is actually what I'm looking for, so 0.0594. So this probability will be 0.0594. So change it into a percent, move the decimal place over 2, so 5.9%. So not very high, right? So not totally unlikely because it's not more than 2 standard deviations away, but it is close to 2. If you were to round this, it would be negative 1.6. So it's closer to 2 standard deviations than it is to 1. So that is doing it by hand and using the table, or using z-scores and then looking up the table. But we can also use StatCrunch. In order to use StatCrunch, we're going to need to remember the mean is 22, the standard deviation is 9, and x, we're looking for the probability that x is less than 8, right? Is less than 8 hours per week. So let's go to StatCrunch. And we're going to go to Stat and Calculators, Normal. So there's our normal, and we're going to put in our mean is 22, our standard deviation was 9, and we're looking for the probability that x is less than 8, and compute, and there it is, 0.0599 in this case. And this does it a little more exact, right? With the z-table, we're approximating our z-score to 2 decimal places, whereas this allows the data to be more exact. So 0.0599. From StackCrunch. So it's still pretty close. So they are pretty close, but StackCrunch gives you a little more exact. So those are the two ways that you can do this problem. Anytime you're using technology, make sure that you include screenshots. If it's a quiz or a test, make sure that you include the screenshots of your StackCrunch. So in this case, I would go back to StackCrunch and take a screenshot of this and show that that's what I did. Okay. Email me if you have any questions. Try the last problem on your own. The heights of men are normally distributed with a mean of 68.6, and then Google the one for Shaquille O'Neal and see how far away from the mean is he. All right, email me if you have any questions.